unique Jupiter is as a radio source, and it has some very interesting characteristics in terms of predictability when you might see Jupiter as a radio source. So it's to the point where Radio Jupiter Pro software was created to allow you to predict when you might be able to see Jupiter as a radio source. And Jim Sky kindly wrote Radio Jupiter Pro for that purpose. So Jim Sky will explain a little bit about how to use Radio Jupiter Pro for that purpose. So.
Okay, I'm going to... All right, well, I'm going to try to go through this very quickly and get you all out of here and get you to lunch. This is the prediction program. It predicts when you might receive Jupiter, when you have the highest probability of receiving Jupiter, and it also tells you where Jupiter is going to be in your sky, which may have some bearing on your what you do with your antenna and that kind of thing. We'll skip setting yourself up in there, and let's go right to this chart that Chuck had up here earlier, and this is the CML-IO phase chart. So very quickly, Jupiter throughout the day passes along that line that you see it on, and those are hours in the day, UT. So you can follow along where Jupiter is going to be at any time of day. This was based on a chart that Jim Tiemann had in his dissertation, I think, or published it. I saw that, and it's been redone, and data that Chuck and had put together, and so this is all based on real data, and my original one was based on my artistic ability. It wasn't very good. Okay, you can see along here is the CML, or the central meridian longitude, and on this axis is the IO phase. So that's an important chart. You'll want to ponder that a little bit. Now, I wanted to bring that up first. Let's bring up this one. This is a little sky map that shows where Jupiter and the Sun are at the current time from your point of view on Earth. And you can see that they're quite close together right now, with Jupiter trailing the Sun by, about an hour and a half or so. And this pattern right here is a particular beam pattern. And you can adjust that beam pattern. You can load different antennas. That would be if you had a dipole, a dual dipole array with one of the dipoles flipped. That would give you a dual pattern. It would give you a pattern like that. But let's just go to a in phase. That should be more like right overhead, and that's just what you'd be using right there. And so you can kind of see when it gets into the 3D points of your beam. These are just estimated. This is not done with EasyNet or anything. We just roughly take, it's done with circles or ellipses. We just roughly take the beam pattern in one direction, the beam pattern in the other, draw an ellipse, and that's good enough for this kind of work. In the center, you see those little lines. That's actually the way the antenna elements are pointed. The little H in the center, very center there. Okay. Now let's get to the actual prediction. Okay, now here is where we, this little crystal ball here is, we get to actually predicting. Now this crazy chart up here, let me see here. I'm guessing is that, oh yeah, okay. It has a lot of information in it. And you look over on this side, you see that the different Jupiter mission modes. So this one has D on it. You normally won't be using that. For this, I sacrificed IO. This was just a proof of concept to show that you could change this, and you could set these parameters up differently. We sacrificed IO, what do we sacrificed C so we could put IOD, because you can only fit so many things on here. Here, you see, whenever this background is light, that means Jupiter is above the horizon. This over here, the blue area, is Jupiter is below the horizon. No sense looking for it then. You got the GMT, your local time. That helps me a little bit. The sun visibility. You can see here's where the sun rises and sets. You can see the brightness at its peak, and that's sort of the same with Jupiter too. So you just get an intuitive idea of where Jupiter is in the sky. And so if I look at this chart, I see this little flag right here that shows B and IB. Of course, whenever there's IOB, it's got to be in the B region. So this is IOB. I say, oh, well, look, there's IOB right as Jupiter is rising here. So if I had a really low angle of antenna, I could probably catch it. So let's predict it. If you want to go for another day, you can just go to the next day like that, and it'll keep recalculating it. That kind of thing. This is not a good time of year to be doing it. Let's go to, we'll change it to October, and things will be better. Down here is just what would you say? Because it's like a spreadsheet that shows you when the different modes will be active. And you can customize this, print this off, and it'll give you can do this for the whole year if you want. Give yourself a schedule that you can post and know when the best times to observe are for the year. Now, we've changed the date there. So let's say I wanted to see what this B, where Jupiter was going to be here. If I right-click on that and show available views for this time, now these other views that we had over here, and most importantly this one, should shift to that. So there, see Jupiter is in the B region. Not a very good chance of hearing it there. We can kind of find out the probability by putting a mouse on it. And that's 12%, but it's not 12% of the time you're going to be hearing Jupiter. That's if you took help me with this, Chuck, maybe, all of the
observations over 50 years.
Yeah.
What is the likelihood that you would receive a mission at that particular IO longitude and central meridian longitude?
Well, okay, yeah, okay. That's the word of it. Down, you can also take a little snapshot of this if you want. That little camera there. Put it on your clipboard. Stick it in your Word document or whatever you're doing to document what you're doing. And let's just see where the other thing is, where Jupiter is in the sky at that time. Yeah, you still have. You can see the sun is much lower in the sky there. Okay, and there's just a couple other views here that I want to show you really quickly. This one kind of helps you plan the year a little bit. I kind of like crazy looking graphs. I've always kind of like developing those. Now, this comes up a little slowly because it's actually the way it's doing it is iterating through the whole year. And it's doing all the calculations for every hour of the day throughout the whole year. So it takes a while for this to develop. But you can see where the sun is up in yellow, and Jupiter is dark green, and when Jupiter and the sun are both up at the same time, it's the regular green. So the times that you really are best to see Jupiter is going to be when Jupiter appears by itself. So we can see that January was a very good time to see Jupiter from midnight to about 9 a.m. The sun came up late, wherever this is set for. So that's basically the idea behind that. This is you won't plot this too often. This shows the D sub E, or the geocentric declination of the Earth. Now my concept of this is if I was standing on the rotational equator of Jupiter and looked out, and where would the Earth be above or below my ecliptic, I guess. So we oscillate from Jupiter's point of view between about plus 3.5 to minus 3.5. And for some reason, and I'll talk about this more in the science, I think, that has a great bearing on how probable it is to see Jupiter, and how strong the signals are. It seems to be correlated with that too. So right now we're getting ready to dive into the point where Jupiter will not be so great. It's been Jupiter observations have been awesome the last few years with the low solar interference and the high D sub E. And there's an observer log in here too, but I won't go into that. There's one last little thing here. You can run scripts and things from here. So it's possible to actually control an antenna, set up an alarm, print something out to a file based upon where Jupiter is in the sky, or one of these modes, if they're active or not. But there's facility here for you more industrious people to write little scripts, and based on Jupiter's position and the situation with I/O and the CML phase. So I'm going to stop there because software demonstrations are boring. And so, if there are any questions about it?
Hey, Jim. Would you mind going back to the probability plot and just take 2 or 3 minutes to go through that in great detail and describe how the lines that show where Jupiter are, does that relate to the probability plot? If it does at all, maybe not.
Oh, you still have the same number of days left.
It hasn't changed.
Yeah, it hasn't changed.
It's been that long.
Okay, so when you say this,
Right.
this one.
Right.
Uh-huh. Okay, well, I hope I can explain this well.
So I might can shorten. Are you saying that at 12 GMT would have been a great time to see Jupiter? Because it's at 16 GMT now. Is that right?
That's right. If you could, yeah, that's possible. Notice, however, that you have to be on a different place on Earth to have seen it, because the color's not showing up very well. But that line is kind of a green right through there. It looks kind of green. You can see here the line. That means Jupiter is below your horizon. So you want Jupiter to be on a white part of that line, and hopefully several hours into it, so it's up high in your sky at that point. Now, if you, let's see if I did it.
Well, Jim, for instance, if a person was wanting to receive that IOA event up there, based on the plot that you're showing there, not much chance, is that what we're saying? Or zero probability likely?
Well, yeah, right, zero probability there. For you, at this moment.
Right.
Okay? Now, if I put the pointer on there, that just shows the probability that's in the map. Okay.
Right.
But for that to be the case, it would need to be over your head.
So basically, if you want to go to an event that you wanted to see, or hear rather,
You go back to that prediction map.
uh-huh.
And then you go through here, and let's go back to October, because that's a pretty good month. Predict the events. Okay. You go through here, and what I would do, I know a IOB, it's going to show me a red bar plus a blue bar. There's B and IOB, see? So let's go next day, see when one of those shows up. There you go. It's very low in the sky, though, see, because it's not in the center of this band.
Right.
But now I'm pretty sure there'll be the little patterns kind of develop that you'll kind of notice. I think if you have a IO, oh, let's go back, because there was an IOA. An IOA, that's going to be a very good IOA to observe. Because it's high in the sky. Jove, oh, I don't have the other views up. Here, let's just go ahead and bring it up.
So in that particular case, of course, this looks like
Oh, I
the
do
sun
know.
is,
Okay.
sun is up at the same time, though, right?
Right. It's just a second here. All right. That's going to modify this one so you can see it. There you go. It shows Jupiter right in the middle of IOA.
Oh, yeah.
So that's the way you find it.
But the sun is also up at that same time, if I'm looking at the chart right up there, so basically,
The sun, yeah.
so you couldn't observe that.
Well, that not necessarily.
Really?
Since the sun has been not very active, and thus it's not been exciting. If you're a ham, you've probably been lamenting the fact that it's been not affecting the ionosphere very much. But it's very good for us. And I think, when's the last event that you observed, Dave? I mean, it's been just
3-4 days ago.
so he's seeing events now with Jupiter 1 hour. He has a very good antenna, very good setup, but he's seeing it now, and we've had lots of daytime observations in the last year or two, and you know, so it's possible. It's worth trying, especially in the morning. I think before the atmosphere or the ionosphere gets too excited.
Okay.
Is there any more?
Yeah, let me just point out something you said about the long-term effect, this declination effect, is that it's an orbital effect, and that 3 degrees is due to the tip of Jupiter. But that affects the beam of the emission that's directed towards Earth. And when we go to low dBs or negative dB values, yeah, the probability of receiving emission is lower, particularly for this non-IO related stuff. The IO related sources are still there, so we just tend to focus on those when we have low dB values, but the others are still highly probable.
What is this very good antenna setup that you referred to a moment ago?
Well, I think
Is it Yankee, a directional Yankee?
no, I think it's an array of dipoles, but it's bigger than your standard Jove array. Dave will probably, will you be describing it? He'll describe that to you. It's a sort of a big effort, but he's done it, and it works very well. Any other questions? Okay, again.
Thanks, Jim.
Thank you.